Hello friends, welcome to follow up. Let's have a look at problem 1027, longest arithmetic subsequence. In this video, we are going to explain a solution based on dynamic programming. So here we are given an integer array called nums. So we are required to find the length of the longest arithmetic subsequence in nums. So here are three examples. In the first example, the output is 4. The reason is that this list itself is an arithmetic subsequence or sequence. So in example 2, the output is 3. So the longest arithmetic subsequence is 4, 7, 10, right? The gap is 3. So in example 3, so the output is 4, and the longest arithmetic subsequence is given by 20, 15, 10, 5, and the gap is -5. The constraints for the problem are the following. First, the list itself has a length at least 2 and at most 1000. So this basically tells us the return for this problem is at least 2. The second constraint is that the element in the list is in between 0 and 500. So which actually tells us the gap is bounded in absolute value by 500. So with that said, basically we are ready to look at the code. So for this problem, we are going to first get the DP interpretation, and then we do the coding, and afterwards we run the examples. So here the DP interpretation is the following. So I'm going to use DPI diff. So this diff is the gap between the current element and the previous element in the arithmetic subsequence. So the number of differences is not known a priori. So this is the distinction point for typical DP. Here from this is a different point for in this problem with the typical ones. So here the interpretation is the following. So this DPI diff is the length of the longest arithmetic subsequence ending at nums I, so with gap diff. So here I'm going to use -1 because this way we're considering the length of the difference sequences, right? For example, we have this one is a arithmetic subsequence, its length is 3. So if we consider the difference, so this should be a constant sequence, the length is 2, right? So with that said, let's first write the code, and then we explain the code by running it out. First, I'm going to have the length of this nums just for convenience, and then I'm going to set the result to be 1. So this result will be representing the difference subsequence for now, and then we just need to return the final state of result plus 1. And then we are going to initialize the DP, right? So for this, I'm going to use a list of dictionaries. So we don't use a list of lists because the inner list is not, the length is not fixed, right? So what I'm going to do is DP equals dictionaries. So let's use collections default dict. So we can set all elements to be 0, right? With value 0 at the very beginning. So for, let's see, for a dummy index in range n, right? And then we are going to do DP update. So in between, we can also update this result state. So we always take the maximum, and then we return the result plus 1, right? So here, let's iterate for I in range n. So the current element will be nums I. So we want to update the DPI, right? So we want to update. The goal is to update the DPI. So this is the dictionary at index I. So this dictionary will store the length of different sequences of the corresponding arithmetic subsequence with gap given by the difference with the previous numbers. This to be made clear. So then the current map we're going to update is DPI, right? And then what we're going to do is to consider all the possible gaps consider all possible differences or gaps. So this we need to iterate for G in range I, right? Then the gap or the difference will be the current number minus nums G. So notice that the dictionary at index G in the DP records the difference sequence length with certain gap, right? So we just need to increment that length by 1. So now let's consider the previous map or previous information is at this one, because here we are considering index G, right? So then basically we want to find the length, right? The length of the previous map at this diff. So this means the longest difference length, sequence length, ending at index G with gap diff, right? So then the corresponding length will be added by 1 at index I, because now we produce a new diff, right? So now what we are going to do is the current map diff will be the previous one and plus 1, right? And then we just need to as dpi to be the current map. So meanwhile we can update this result, max, the previous state, and the dpi, or the current map at diff, right? The same thing. And then we just need to return result plus 1. So this actually forms a full solution format for this specific problem. So before we run this code specifically, let's first do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. So now let's run it specifically, right? Let's look at the two examples in the problem description, example 1 and example 2. So for example 1, let's first see the DP initialization. So we're going to have 4 empty dictionaries at the very beginning, right? And then we are going to look at each number. So at index I, so this actually, because there's no previous numbers, no gap produced, so no real work, just continue. At index I equals 1, so what we have, so we need to check the previous index, right? So we check J equals 0. So what we have, the difference is in this number 6 minus the one at 3, that is 3, right? So this gap is not appeared in the dictionary at index 0 here. So we're going to have this one 3 0, right? And then we are going to update the dictionary at index 1, that is the value of this 3 plus 1, right? Because here is 0. 0 plus 1 is 1. So now let's look at the second one. So we need to check J equals 0 and J equals 1. So now, because at index 1 and index 2, so the number is none, right? So none minus 3. So we're going to have 6. This diff is not in the original dictionary at index 0. So we're going to have 6, 0. And then at index 2, so we're going to have 6, 0 plus 1, that is 1. And then at J equals 1, so we're going to have 9 minus 6. So we have 3 again. So 3 appears here, that is 1. So here we're going to have 3, and then here is 2, right? So this is for index 2. Now let's look at index 3. So we need to check J equals 0, J equals 1, and J equals 2. So for J equals 0, so we are going to consider 12 minus 3, that is none. So none does not appear in this dictionary at index 0, so we have none 0. So here we have none 1. So now let's look at index 1. So we have 12 minus 6. We're going to have 6. So 6 does not appear in this one. So we're going to have 6 0. And then at here, so we're going to have 6, 1. So now let's look at j equals 2. So we are going to have 12 minus 9, that is 3. So 3 appears at this dictionary at index 2. So we're going to have this one is 3, 2 plus 1, that is 3. So the largest values among all the dictionaries is 3. So the return will be 3 plus 1. So this is the first example. So to better understand the program, now let's look at the second example. So for the second example, the return is 3. So now let's first look at these numbers. So the DP initialization is nothing but, so we have 5 empty dictionaries at the very beginning. So similarly, at index 1, no real work. So we're going to continue. At I equals 1, so we're going to consider, so the number is, the number of the current is 4, right? So we're going to check j equals 0, right? So at j equals 0, so we get a 4 minus 9, that is negative 5. So negative 5 does not appear in this dictionary, so we have negative 5, 0. So then at index 1, that's the I, right? So we are going to have negative 5, 1. So next, we're going to check for I equals 2. The current number will be 7, right? So we need to check j equals 0, j equals 1. So at j equals 0, we get 7 minus 9, that is negative 2. So negative 2 does not appear in the dictionary at index 0, so we get negative 2, 0. Then for the dictionary at index 2, so we get negative 2, 1. Then for j equals 1, so we get 7 minus 4, that is 3. 3 does not appear in the dictionary at index 1, so we have 3, 0. And at index 2, so we're going to have 3, 1. So this is for I equals 2. So now let's look at I equals 3. The current number will be 2, right? Then we need to check j equals 0, j equals 1, and j equals 2. So at j equals 0, what we have is 2 minus 9, that is negative 7. So negative 7 does not appear in the dictionary at index 0, so we get negative 7, 0. Then at index 3, so we're going to have negative 7, 1, right? Then at j equals 1, we get 2 minus 4, right? That is negative 2. So negative 2 does not appear in this index dictionary, so we are going to have negative 2, 1. So at index 3, so 0, 1, 2, 3. So we're going to have negative 2, 1. At index 2, so we get 2 minus j equals 2 is corresponding to 7. That is negative 5. So negative 5 does not appear here, right? So we're going to have negative 5, 0. So we get negative 5, 1. So this is for index 3. Now let's look at index 4. So this corresponding to current equals 10, right? Then we need to check j equals 0, j equals 1, j equals 2, and j equals 3. So at j equals 0, we get 10 minus 9. That is 1. So 1 does not appear here, so we get 1, 0. So that what we get for this one will be 1, 1. So now let's look at j equals 1. So we have 10 minus 4. That is 6. 6 does not appear in index 1, so we get 6, 0. So we get 6, 1 here, right? So now let's look at j equals 2. So we get 10 minus the number at index 2 is 7. So we get 7, that is 3. So 3 does appear here, right? 3, 1. So we are going to have 3, 2, right? And then look at j equals 3. So we get 10 minus 2. that is 8. 8 does not appear in the dictionary at index 3, so we're going to have 8, 0. So now we have 8, 1. So then we can prepare the return. The maximum value is among all the values is nothing but the 2 here, right? So we're going to return 2 plus 1, that is 3. So if we compare this dictionary with here, so we get 5, negative 5, 0, negative 2, 0, negative 7, 0, 1, 0, and negative 5, 1, 3, 0, negative 2, 1, negative 1, there should be 1. So here is difference, right? So it's check that. So but it is not essential. So we have negative 2, 1, 3, 1, negative 5, 0. So we get negative 7, 1, negative 2, 1, negative 5, 1, 8, 0. So the last one is the same, right? So with that said, I guess that's about it. So if you're curious, let's fix this point. So we can print out this DP. So for this one, right? So the difference lies in negative 2 and 0. So this is the first, second one. Oh, actually, here, negative 2. Yeah, negative 2 does not appear in z equals 1. So yeah, here is should be 0, right? So at index 1, yeah, that's right. The priest is a typo. So with that said, basically we give a very detailed explanation for this code and this example. So you are welcome to write out some other variants of this solution.